Okay, so this is question 2000 from a 2019 question 3. It has been modified slightly, but it's generally the question. The actual question wasn't mermaids and unicorns, and it wasn't Lucky Charms. But we were trying to prevent people from going online and looking it up. So here we go. A researcher surveyed a large group of mermaids and unicorns about whether they have eaten their Lucky Charms as prescribed. The responses were categorized as never, sometimes, or always. A relative frequency of each category is shown in the table. One individual from those surveyed will be selected at random. What is the probability that the individual selected will be someone whose response is never or who is a unicorn? So we have never or who is a unicorn. And so this is my never. I'm sorry, I said never and who is a unicorn. This is the key word, and. So they're selecting it at random from the total. So the way I like to think of this is my intersection, which is right here, that value over the total equals 0.0636 or 6.36%. Now, I'm going to be quite honest with you. On this particular problem, you did not need to include 1 because mathematicians don't care about dividing by 1. However, there are a lot of times that these, instead of being probabilities, will actually be numerical counts, in which case you are definitely going to need to show that number in the bottom. All right. So this is just habit. If you had actually just gone straight to this one, you would have been okay this time. All right. But get in the habit of saying the intersection over the total for that type of problem. And once again, this was the key word that let me know what I was looking for. All right. Number 2, what's the probability that the individual selected will be someone whose response is never or who is a unicorn? And by the way, Ms. Lamb and I talked about this. This was a mistake on my part. We should not have included this on this one. So we're not actually going to count this, but we thought since we're here for Stat Saturday, we'd go ahead and talk about this. But when we're grading it, this won't count for you or against you. So in this case, or it means add. So never plus unicorn minus never and unicorn. And you're like, well, why'd you do that? So let me see if I can try to help make some sense of this. In probability, we will talk more about this, but we have the never group right here. And basically, the 1200 is made out of these two values. And then we have unicorn, which sums up to 5,300, and it's made out of these 1, 2, 3 added up together. Well, so we wanted never plus unicorn, and you're like, well, never was 1,200, and that's right, and unicorn was 5,300, and that's right. But notice I have a problem here. The 63 was counted twice. The 0.0636 was counted twice. And so because it was counted twice, once in the never and once here, I have to subtract it out. So this would have been the actual correct answer, but once again, we are not going to count that question for this quiz, and I should not have included it. Part 3, what is the probability that the individual selected will be someone whose response is never, given that the person is a unicorn? All right, given is the key phrase here. Given tells me something is in the denominator. All right, it's going to be the joint probability over the marginal. All right, so we were given that they were a unicorn. So this is what's given. Given means that I'm no longer looking at the total amount. I'm only looking at what I was restricted to, and I was restricted to unicorns. So I was restricted to unicorns. It's no longer the total in the denominator. So I have 53 in the denominator. And then we wanted never. And so my intersection over my given My intersection over my given, or 0.0636 divided by that equals this. I have to see this. This is a must. All right. For the individual surveyed, are the events being an individual whose response is never and being a unicorn independent? Justify your answers. Ms. Lamb will probably discuss this more, but I want to briefly say that at this point, you only know how to do independence by proportions. That's not the way College Board is going to want you to approach it later, but you do need to know this concept, so we presented it here. All right, so at this point in the year, we only know that independent events are proportional. As a consequence, we need to check proportions, so we need to compare the never column to the total column. All right, so 0.0636 divided by 0.1200, it turns out it does equal 0.5300 over 1. And because the proportions are equal, the events being an individual and a unicorn are independent. All right. And thank you.
Okay. So we're looking at Scenario 1 PDF and the Google Coaching Classroom for the official rubric. And as Mr. Spencer stated in Part A-I, that there wasn't a lot of work to be shown because the table itself was already converted to probabilities. So you just have to list your number. For double I, like we're not grading it. I did want to share with you guys a different way that you could have done it. I know that my GT students, we did probability, but not every geometry student did different probabilities work in their geometry class. But you could have solved it by doing sums of the mermaid never with all of unicorns, or you could have look on this table here. I'm assuming you guys can see my table work. Can you see the different tables with yellow and green cells? You could also have done never mermaid and then individually added all the unicorn probabilities. So I just wanted to show you another way, and some of you might have had some experience before in a geometry class, but since not everybody got that experience, we're not counting that question for this particular quiz. But all of those different methods would have been appropriate work to get full credit from College Board. So you would just have to show your addition work of those cells to get that credit. For Part B, what we're looking for is proportions. So you have to show, and there were different ways to show the proportions, to show that the proportions were equal, so therefore independent. I wanted to make a special note that if you just say independent, but you do not show proportionality in this question, that is not justification. So you wouldn't get full credit for that. So it's super important that you guys are showing your work. Basically, that's what AP College Board is consistent with across the board on all problems. Showing work might be an equation, showing work might be referring back to a table graph, shape of the graph, things like that. You have to justify your answer always. Any questions on how College Board would have graded this for you?